All right, let's take a look at chapter 12. Find the secant of A. We know secant is the inverse of cosine. So instead of adjacent over hypotenuse, we're looking for hypotenuse over adjacent. And so the hypotenuse of this triangle is 34 over the adjacent, and we're referring to angle A. So adjacent to angle A is this side right here. So we're going to have to do, looks like we need to do a little Pythagorean theorem to find it, unless you know your Pythagorean triples. So we've got to take 34 squared, and we're going to subtract 30 squared, which is 900, from that. So x squared equals 256, and square root of that is 16. So we know that x is 16. So that's the adjacent. So we're doing 34 over 16. If we simplify those, they're both divisible by 2, 17 over 8. So we get A for an answer. Go to the next page. Which equation can be used to find x? So 32 degrees, x is adjacent, 7 is hypotenuse. Adjacent hypotenuse is cosine. So it would be cosine of 32 is equal to your adjacent over your hypotenuse. We see that that's actually not listed. The reciprocal of cosine is secant, but secant's not on there either. As it turns out, the correct answer to number 2 is actually not on here. It was not listed. That was kind of a mistake. So no worries if you couldn't find the right answer. It's not there. Number 3. Find A to the nearest degree. So it looks like I'd be using opposite and hypotenuse. That's a sine problem. So since I'm looking for the angle, I'm going to do inverse sine of 15 over 26. Make sure your calculator is in degree mode. You'll hit second sine, 15 over 26. And you get about 35.2, so 35 degrees. B would be your correct answer. Number 4, we're going to rewrite in degrees. So we'll take 180 over pi. Pi's cancel, 180 over 4 simplifies. So 5 times 45. So we're going to get 225 degrees. So that's G. Number 5, we want to be coterminal with negative 400. All of the answers they give are positive. So I'm going to start adding 360. So if I add 360 to negative 400, I get negative 40. Negative 40 is not on here, so I add 360 again. You do that as many times as necessary until you get one of these angles listed. 320 is what I get, so C is the correct answer. Find the exact value of cosine if the terminal side's 6, negative 8. So I might draw a picture. It doesn't have to be exact, but 6, negative 8 would be in the 4th quadrant. The x-coordinate of 6, y-coordinate of negative 8. If I do Pythagorean theorem, I get 10. And so cosine of the reference angle here, adjacent over hypotenuse, that's 6 over 10, simplifies to 3/5 G. All right, cotangent of negative 315. If we think about negative 315, we go to the 1st quadrant. 45 degrees would be our reference angle. So then we know it's a 1 squared root of 2. We're looking for cotangent, which is the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite. So 1 over 1, 1 is our answer. Okay, number 8, sine of negative pi over 6. Let's draw that triangle. So pi over 180 divided by 6 is 30, so we go negative 30 degrees. So it's a 30, 60, 90 triangle. Our opposite is 1, it'd be negative since it's down. We have square root of 3 for an adjacent. 2 for the hypotenuse. They're asking about sine, so that's opposite over hypotenuse, negative 1 over 2. So number 8 should be F. Number 9. So triangle ABC. We don't know that it's a right triangle. Looks like it's going to be a law of sines problem, because I know both C's. It is a case where we have to check and see how many answers there are as well. As it turns out, there's actually 2 triangles in this one, but this doesn't build into triangles. It only uses that primary one. So I'm going to proceed. I know that that's the case, but let's go ahead and just plug in law of sines. We're going to have to do that regardless. So let's just plug it in. I think that's going to be all we really need to do to solve this problem. So we're looking for b over side b. So we're going to cross multiply. Divide by 22. And then I'm going to need to get b by itself, so I'm going to do inverse sine or second sine of that whole fraction. I'll type it in here so you can see. Second sine of 42 sine of 30 divided by 22. About 72.7 degrees. So that'd be about 73 was one of the answers, A. And I believe, so if 73 is an answer, its supplement is 107. 107 would have been angle B in the other triangle, but 107 isn't even listed here, so that's why we're not worrying about the fact that that one was 2 triangles. Okay, number 10. Find the area of the triangle. So we need our area formula. Area formula is 1/2, and let's see which sides do we have. We have side B and C. So 1/2 times side B times side C times sine of angle A. 1/2 B, C, sine A. That's the formula we're using right now. You can also switch out the letters for whatever is appropriate, as long as the angle is the other letter than what you use for the sides. So 1/2 times 8 times 14 times sine of 55. We get about, it looks like we're rounding to nearest tenth here, so 45.9 degrees. Or I mean not degrees, but meters squared, H. Which triangle has no solution? So as I look at the angle, I notice only one of the triangles has an obtuse angle. So C has angle A, which is obtuse. If A is obtuse, side A better be the longest side. So check side A, it's 15, but 15 is longer than B. So that one's okay. That one doesn't have no solution, so I can cross that out. So now in the rest of these, if side A is longer than side B, then I can throw that out. So letter D rather, A is longer than side B, so that's going to be one triangle. That's okay. You can throw that out. So now I'm down to A and B. Which triangle has no solution? So we need to check the hypotenuse, or the altitude. That's going to draw a triangle here. We'll call this angle A. Side A, side B. Okay, so we've got 45 degrees. Well, it depends on the problem. But what we're going to need to do is check the height of this triangle. So to check the height of the triangle, so we can compare A to it, if A is shorter than the height, that's not going to work. So my guess is, because let's see, my guess is if one of these isn't going to work, it's going to be B. So I might check that one first. I could check either one, but I'm going to use the numbers in B. I guess I'll just do both. So in either way, I'm going to need a sign problem, because I know B, I'm looking for the opposite of A. So on part A, I'll use the 45 degree angle. Sine of 45 degrees is equal to the opposite, which is the height, that's what I'm looking for, over the hypotenuse, which is B, which is 4. So when I solve that, I'll multiply by 4. So I'll take 4 times sine of 45, 2.8 roughly. As 3, it's larger than that, so that's okay. So A is not a problem. Let's check B now. So this time my angle is 15 degrees. Sine of 15 degrees is equal to my height over my hypotenuse, which is 19. So I'll take 19 times sine of 15, 4.9. Is my A larger than that? No, it's not. It's actually less than that, so there's the one that's not possible. My side A is shorter than my height. There is no triangle. Okay, number 12. All right. We're going to do, it looks like a law of cosines problem here. So we're looking for side A. We know side B. We know side C. Minus 2 times side B times side C times cosine of angle A, which is 15. I'm not even going to bother simplifying this. I know if that was an A squared there. I know what I'm going to have to do is square root. Just going to type in that entire thing all at once. So I'll do square root of 19 squared plus 12 squared minus 2 times 19 times 12 times cosine of 15. So about 8.0. So J would be our answer. 12 is J. All right, which triangle should be solved by beginning with law of sines? So we would need, let's see, well, okay, if you look at B, we cannot start with it in B because we know angle B, but we don't know side B. We can't find it using law of sines, so I can't start with that one. C, we have angle A, and only angle A. I don't have side A, I can't do that one. D, I don't have any angles at all, so I can't start with it. So I think only A, angle A, or option A gives us angle A, and we know side A. So we can use law of sines in that problem because we know both A's and we know one other piece of information. So 13 is A. Number 14, determine the period. So maybe I'll say okay, here's a minimum, right here is 0. Our next time we get to minimum is 24. So it took us 24 to complete a full cycle. That would be the period. So J. Okay, 3 more problems from chapter 12. Find the period. Take 360 divided by the absolute value of b, b being 5, absolute value of 5 is 5. 360 divided by 5 is going to be 72. Looks like they made it, they took 72 and put it into radian mode. So 72 over 180. We can simplify that to 2/5. So 2 pi over 5. So D is our answer there. Okay, solve this one. All right, so this technically should be a capital C. So cosine, inverse cosine, we're looking at quadrants 1 and 2. Here it's positive. Cosine is positive in the first quadrant. So we're going to draw a triangle in the first quadrant. Adjacent over hypotenuse. We got a hypotenuse of 2, and adjacent square root of 2. Oh, those sides aren't really any of the sides of our special right triangle. We may realize that, oh, that was actually rationalized. If I divide both top and bottom by square root of 2, I get 1 over square root of 2. That's more what we're accustomed to. So an adjacent side of 1, a hypotenuse of square root of 2. I know it's a race, so it's a little hard to see. This is a 1, this is square root of 2. This is a 45, 45, 90 triangle. So our reference angle is 45 degrees. It is in first quadrant, so there's our answer, H. Number 17, arc cosine of 1/2. So cosine is positive. We're going to first quadrant again. So our cosine adjacent is 1. Hypotenuse is 2. We recognize that that's a 30, 60, 90 triangle. The other side is square root of 3. Now of that reference angle, they're wanting us to find tangent. So we do opposite over adjacent. Opposite is square root of 3 over 1 is just square root of 3. C. And that's the end of chapter 12.